for today, we have one item on the agenda. If you have anything else, please add this. Today, we're going to be talking about Mesh External Service, which is a new policy that we are currently working on. That its aim is to replace the external service policy that we already have in Kuma. I'll start with summing up the situation with the external service V1, which is the old one. Currently, we have support for a custom domain. So, for example, http://bin.mesh. The field networking address can be DNS or IP. We can provide a custom TLS config. External services are only accessible from a specific zone. When we have egress enabled, the traffic will go through egress automatically. And it's possible to apply policies to external services using egress. And this works with our feature called auto-reachable services that trims the config automatically. This is really good, but this policy also has a couple of problems. When we have a Kuma IO/service tag, this cannot be equal to the networking address because there's going to be problems resolving the name. When there are two external services that have the same networking address, we will have a DNS clash, and we'll, if I remember correctly, just round robin between the two of them. The same is happening. No, we won't. There's going to be an error with the DNS from the DNS component that we have a clash, and one of the policies won't work. Another thing is that the external services with the same Kuma IO service, those will be merged. So if you have the same name in Kuma IO service, the external service will just round robin between all of the ones that have the same name. We have some problems with applying policies to external services, so we need to rethink the support for that. And there's no support for wildcards, so you cannot do something like the API. This won't work. You have to manually define all of the external services that you want to communicate with, and this is problematic for cases like you have Kafka broker with multiple domains, and you just want to be able to go through merge when contacting that. And there are some use cases that people requested. So they have, for example, a gateway in the mesh, and they want to contact services that are outside of the mesh. In this particular case, that was 5,000 services outside of the mesh, mostly HTTP. So they don't need any external services policies settings. They just want a sort of a extension on the pass-through that we provide on the mesh level. So more of like a allow list that has low footprint. You don't have to write a lot of configuration, and it has also low footprint on the proxy side. People are also requesting like they having their databases in a SaaS environment, and they want to send TCP traffic to that. The Kafka brokers example that I've already mentioned, and some of them want to have external services be able to target policies at, and the wildcard support that was mentioned in the problems. And now if we look at the current model, we have the fields that I mentioned, we have the tags, and we have networking, the address, DNS configuration settings, and out of that, we will create a external service with http.mesh, and we'll also hijack this name to go through mesh. And now let's look at the model that we're suggesting to implement. As I said, this is still work in progress, so things are going to change here, but we're in the process of designing this and creating the new resource. So we have the usual, the kind is MeshExternalService, and we have the usual metadata, which contains the name, the namespace, and some additional labels. And then in the spec, we start with access, which is a variable that allows people to specify if they want this external service to be accessed by egress when egress is available, or via the proxy directly if egress is not yet available. Then we have the match section, which says what traffic I want this external service, like which matching traffic I want this external service to handle. And this can be domains, site ranges, or IP addresses. You can see we have the star wildcard domain first, then an exact domain, a site range, and an exact IP. Then we have ports, which determine which ports are going to be, are the external service is going to be consuming. In this case, we just defined 80, which is the HTTP port. And then we have protocol, and protocol can be one of the protocols mentioned here. HTTP, HTTPS, TCP, TLS, gRPC, and the default is going to be TCP. We're actually going to go into more details and examples when it comes to this, so hang on. Then we have the destinations section, which tell you where to actually route the traffic that this external service is going to be handling. And in some cases, when we can use the strict DNS cluster on Envoy, we can use we can mix addresses and domains and even Unix sockets to route to multiple destinations. Then we have a TLS section, which is a bit modified. It's kind of extended. We have a version where we can specify what is the minimal and maximal version of TLS that we require. We have the same field from the first external service, which is allow renegotiation, so you can renegotiate the ciphers and so on. Then we have a verification section that if you, for some reason, don't want to verify the subject alternative names, you can turn the skip boolean to true. And if you don't specify the subject alternative names, then this will be just taken from domains. But if you want to extend that, for example, you have a custom name for this external service and you want to validate against that, then you can do this. And then we have the CA client cert and client key sections that are similar to what we've already had in the external service v1 version. After all of this is another section called status. And this status section is the Kubernetes status section that we will use to actually give the user back information about this domain that we're trying to, for example, pass through traffic. Is it generated, or was it something that was defined by the user? Was the domain generation successful, or was it not? And we have on the bottom, we have the VIP section, which contains the virtual IP addresses that we assigned. So if you have a custom domain, then we will assign it our internal address, and this is where we're going to report this information. Okay, so this is all when it comes to the schema itself. Now let's dive into some of the examples with the protocols and the like more concrete information on how you would use this. So the first example is just a TCP service that we just have some addresses that we would like to pass through an external service, and for so this will generate a specific listener, and using that listener, we will also be able to expose custom metrics, specific metrics for these targets. So you can actually like segment the traffic and look at the stats of individual things, and not actually have everything clumped together in a pass-through cluster that is called original destination. Okay, so this is first like a really simple example, and now let's look at something similar, but we will add a custom domain that we generate ourselves. This is something that I mentioned near the status field. So this is pretty much the same definition as we had, but we also have another policy, which is called hostname generator. This policy is actually coming from another MIDR that we're currently working on, which is called MeshService. We're reworking the way services are defined in Kuma. And this, and our addition to this hostname generator is a selector for external services. So this hostname generator will look for all the mesh external services that match the name example. So if you have example here, this will be matched. And using the template specified down here, we will generate a domain that contains the name. This is the name that is coming from the metadata, and this suffix .ext.svc. So this is how I think we're missing local here, or local is address from somewhere else. Yeah, but this is how we would generate a domain for an external service that basically has only IP addresses, and that way we can register a domain internally in the mesh for it. Another type of the combination of protocol and TLS is to have TCP protocol and TLS section, and this means that we will do the TLS origination So the traffic from the local service, the traffic from the application is not going to be encrypted to Envoy, and Envoy will take care of actually encrypting the traffic. This case is really useful if you have like a really old service and you cannot modify its source code, like you only have the binary version of it, and you just want to secure the traffic to that from that service to some external resource that is on the internet or on your cluster. So that way you just define the TLS origination on Envoy, and you have encrypted traffic that is leaving your service, and you don't have to modify the source code or in any way. This TCP. This we have a similar situation, but we just have, instead of the domain, we have specific addresses added here. The next case is protocol TLS. So when we set protocol TLS, this means that the service itself will be responsible for doing encryption. So Envoy will not, Envoy and Kuma will not in any way modify the traffic flow. Then we have a case for HTTP plus TLS origination. So it's similar to the previous example with TLS origination, but now with the stocking HTTP instead of plain TCP. And we also have a couple of other cases which are HTTPS. Which is similar to the TLS case. Basically, the client handles TLS. So it's not anything specific. We have HTTP2, which is the same as HTTP, but we will also add specific filters on the outbound cluster, on the outbound listener to have more statistics and just better visibility into this, because we can, with HTTP, we can provide more stats. And we can have HTTP2 with clear text, which is the same as the HTTP case, but we are not going to do Envoy TLS origination. And pretty much the same case is for gRPC, because it uses HTTP2. The difference here is going to be that we are going to add another gRPC filter to have statistics on the response codes that Envoy provides. Okay, so to sum this up, when we basically all of those types require some sort of a specific Envoy configuration. So when we're using wildcards, we have to use original destination cluster. Because basically we cannot like we have to just pass through the traffic, because we cannot detect actually how to like we cannot just create infinite amounts of clusters. We have to just give the original like the client needs to figure out the IP and give it to Envoy, and Envoy will just pass it through. When we have a TLS section, then Envoy is doing the TLS origination. In any other case, either the traffic is not encrypted, or the TLS is done on the client side. And the last thing is we forbid using domains plus TCP, like play domains and no TLS, because in that case, there's no way for us to distinguish traffic from different, two different targets that are on the same port. It's just TCP packet, and there's no header, host, or SNI information to route this to different clusters. Okay, I think we've went through everything that I had for today. Do we have any questions from anyone? Okay, I don't hear anyone. Let me look at the agenda again. I don't see anyone putting anything else into the agenda. Okay, so if this is all of it, then thank you very much. We'll be creating the MADR PRs shortly. So if you're not on this call and you watch the recording and you want to participate, just go to Kuma GitHub and to pull requests, and you should find the external service or MeshExternalService PR there, and you can comment and get involved that way. All right. Thank you very much all for joining, and last call to if you have any questions or any remarks, this is the last moment to have them. All right, I don't see anyone raising their hands. So thank you all very much for joining, and see you in a month for another community call.
Bye-bye.
Thanks.